Welcome to Across the Globe. Today we will learn about working with observables. Observables in Angular are used for managing asynchronous operations efficiently. They are capable of handling and reacting to data streams that change continuously over time. For example, when fetching data from a server in an Angular application, observables can be used to subscribe to the response stream and perform actions like updating the UI when new data arrives. This ability to handle dynamic data streams makes observables a vital tool for creating responsive and interactive web applications in Angular. Observables in rxjs are created using the Observable class. They emit multiple values over time, and by subscribing to them, you can receive these emitted values. For instance, in Python, you can use the Observable class to create an observable that emits values 1, 2, 3, 4, 5 using fromIterable method. Subsequently, by subscribing to this observable and providing a lambda function, you can print each emitted value when executed. When working with observables, you subscribe to them in order to start receiving values. Subscriptions offer methods for handling received values, errors, and completion signals. In the provided example, a source observable is subscribed to. The onNext method specifies what to do with the received value, the onError method outlines error handling, and the onCompleted method specifies the actions to take upon completion. This structure ensures efficient handling of data flow within observable streams. Operators in rxjs are tools used to modify data emitted by observables. They offer capabilities to filter, map, and merge observables efficiently. For instance, in the provided example, the map operator multiplies each emitted value by 2 before passing it along, showcasing how operators can transform data streams. This functionality is crucial in scenarios where you need to alter the emitted values from observables to better suit specific requirements or computations. By employing a thoughtful selection and application of operators, developers can enhance the manipulation and processing of data streams in reactive programming with rxjs effectively. To avoid memory leaks, ensure you unsubscribe from observables by utilizing the unsubscribe method on a subscription object. Failing to unsubscribe can lead to a buildup of retained references, causing increased memory usage over time. This practice helps in efficiently managing resources and ensuring cleanup after the observable is no longer needed. For instance, in a real-world scenario where you have an application that subscribes to real-time data updates from a server, remember to unsubscribe from the data stream when the user navigates away from the page or closes the application. This action will release resources and maintain optimal performance. Observing a traffic light is like working with observables in programming. Just as we wait for the traffic light to change from red to green before crossing the road, in programming, we wait for the observable data to change before executing the next action. The traffic light changing colors signals to us when it's safe to move forward. Similarly, the observable emitting new data signals to the program when it's time to take the next step. Hey, Code Conquerors, ready to level up? With TechLearn ATG, showcase your skills with official course certificates. Just visit our site and start. Need that extra boost? Get tailored learning, 24/7 support and expert guidance, coding smarter, growing faster, and making learning fun. Go to our website across the globe, w.atg.world. The code snippet showcases the usage of observables in Angular to handle asynchronous data streams effectively. In the analogy presented, simulating the behavior of a traffic light changing colors, the observable is created to emit different colors at set intervals, symbolizing the changing states of the traffic light. Initially, the observer emits red as the starting color, mimicking a traffic light's default state. Following a delay of 3 seconds, the observer emits green to indicate a safe passage for pedestrians, akin to the traffic light transitioning to the green signal. By subscribing to the traffic light observable, we can listen for these emissions and react accordingly in the program. The subscription includes handlers for the next emitted value, error handling, and completion of observation. Observables in Angular offer a powerful way to handle asynchronous operations and respond to data changes in real time. The analogy of a traffic light effectively illustrates the concept of observables by highlighting the observation and reaction to changing states, mirroring how observables notify subscribers about new data for further processing. An industrial application of working with observables can be found in real-time communication systems, such as chat applications. Consider a chat application where multiple users can send and receive messages. Using observables, the application can subscribe to a stream of incoming messages and instantly display them to users in real time. This allows for seamless and efficient communication between users without the need for constant polling or manual refreshing of the chat interface. By observing the stream of incoming messages as an observable, the chat application can react instantly to new messages being sent by users, providing a responsive and dynamic user experience. Through the use of observables, the chat application can handle asynchronous events like incoming messages efficiently, making real-time communication between users smooth and interactive. The use of observables in real-time communication systems showcases the power and versatility of reactive programming in providing responsive and dynamic user experiences. Across the globe, industries are leveraging observables in various applications to enhance real-time communication, streamline data processing, and improve user interaction through asynchronous event handling. Keep learning, stay curious, and I'll catch you in the next video.